These two robots are known as the dynamic duo Daft Punk. But they didn't always used to be robots. On the fateful night of September 9th, 1999, an accident occurred in the studio they were working in, and all they can remember was a white flash of light. Once they awoke, the former humans known as Guy Manuel and Thomas Bangalter were robots with robot helmets. These helmets have made many changes over the course of history. You might know them best for their helmets designed for the Random Access Memory album. These helmets are featured in the Get Lucky music video. They're pretty snazzy, I quite like them. But they're missing something. See, back in the Discovery album era, they used to have lights to give the robots faces and, dare I say it, emotion. For the longest time, I wanted to build these helmets. The dream was so big that I didn't see any chance. But I persevered. I learned new skills and I pushed boundaries to make this. The journey to get here wasn't easy though. Let's take it back to where it all started. Figuring out where to start. So obviously there's a lot to tackle with this project. If we take a closer look at the helmet from the Discovery era, we know that it has to be wearable, has a tinted visor, and it's got a lot of circuitry to make everything work. But there's one problem that stands above the rest. Me. No. The main problem with this is that we need LEDs that we can easily tell what to do, or else this whole project is a wash. I want to use LEDs for this project, but most of them just come in single colors, which obviously isn't what we want for this. And tri-colored LEDs do exist and are easy to control on the individual level, but when you try and scale that up to hundreds, if not thousands of LEDs, well, things start to get a little bit complex. This was another project I did. It's called an LED cube. It only had 512 single colored LEDs in it. And you can see how complex it is. Just look at all those wires. I'm estimating that I need 1,000 LEDs for this project. So I've opted to use one of my most favorite things in the world, the WS2812B LED. This is an LED that can be chained together in a series configuration in which we can tell each individual one what color it should be with only 2 lines for communicating to them. That's why I like them so much. They've been my go-to LED for most of my projects once I discovered them. But they come with a catch, as everything does. These devices are surface mount. That means they want to be mounted to a solid, flat board. Have you noticed that Guy Man's visor is actually curved? This is going to be a problem. The way the original engineers solved this problem was they used a more standard LED like this. But as I mentioned before, each one of these LEDs needs its own controllable output, which is exactly what the engineers did at the time. It was crazy. There were wires everywhere. They actually had to give Guy Man and Thomas Bangalter their own backpacks so that they could stuff all the control circuitry in one location. It wasn't practical, and I can see why they got rid of the LEDs in later iterations. You have to remember though, this was bleeding edge for the time. LEDs were still very new, so they did the best they could with the resources that they had available to them. I just happen to have better resources available to me now, so why not use them? With that, I've already decided that I want to use the WS2812B LEDs, as well as I want to use a rigid PCB. But why? That seems counterintuitive. Well, first we have to understand that most standard PCBs, or printed circuit boards, are made with a fiberglass center. Mechanically speaking, if I have a very thin PCB, I should be able to flex it. So if I design a custom PCB and tell the factory to make it as thin as possible, in theory, I should be able to populate the boards with the LEDs, flex it ever so slightly, and then affix it into place. I actually populated one of these boards already, so let's hook it up to power and data and see if we can bend it and still get data traveling across the entire strip. Okay, here we have our little test setup. Here's our LED strip and Arduino to control everything. Let's just plug it in. Okay, so we can see LED strip is getting data. So let's try and bend it.
Looks like we're still getting data. Like, look, that's bent even more than I want it to go, and it's still working. I'd call that a success.
It works! But Captain, how are you going to see through these boards if it's covering your face from bottom to top? Well, did you notice something in the design? You got to look really close. Even closer. There it is. You see those little notches? I actually intentionally put those in, and it does something really cool when you stack them together. It creates little pinholes. Pinholes from a distance that don't really look like they do anything. But when you get closer, you start to see the picture. No pun intended. I like to call this the bug screen effect. I named it this because it's like a bug screen. From a distance, the screen appears to be black. But as you get closer and closer and closer, those holes, from your perspective, seem to be bigger. And you can see through them a lot easier. So it's the same deal with my helmet. Nobody's going to notice it from far away, but when you're right up close to it, well, you can see through it. Amazing. Once the screen was out of the way, I could start focusing my efforts on getting the whole helmet 3D printed. To this date, actually, this is my biggest single piece 3D print. The gold exterior was also hard to figure out. I couldn't just use gold spray paint. It just looked too cheap. So what I ended up doing is sending the whole helmet out to a trophy coating company that, if you remember from when you were a kid, if you got a trophy for participating in, I don't know, hockey or lacrosse or something equivalent. But if you actually touched it, you would realize it wasn't gold. It was just made out of plastic. What they do is a cool process called vacuum metallization, which in short, you put a conductive layer of paint or something on the top surface, and then you use electrodes to deposit a gold-like flake on the surface to make it appear, well, a bright, shiny gold. And that's how I got this beautiful finish on my Guy Manuel helmet. As for the rest of the helmet, there were a few other things I needed to take care of. A few different LED PCBs that weren't curved that went into the helmet, the power supply, which was a LiPo battery, of course, and the driver circuit, which was another custom designed PCB I made. There were so many bloody PCBs in this project. I don't know how I got it done on time. All that was left was some assembly. Can you believe this project only took me 4 months? Only 4 months? Yeah, I don't think I would ever do that again. Anyways, if you want to see me make the Thomas Van Galter helmet in 4 months, please subscribe, like, and comment below. Oh jeez, here we go again. Around the world, 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 around the world. around the world. No copyright for me, because I'm singing a song around the world, around the world. I hope you enjoyed that.